Hello everyone, welcome to our research. My name is Yunus Ocak. Today me and my friends will mention to you about our research. So let's get started with our research topic. Our research topic is statistical analysis of the correlation between player attributes and the average points in the professional basketball. So today basically we will make an introduction and then data collection description, data analysis, normality test, hypothesis, flatness of fit test, then a regression model, ANOVA, and parametric test, and references. So let's make a quick introduction to our research. In this research, we basically look for the correlation between NBA players' physical attributes, for example, height, weight, and shoe size we use in the research. And with that physical attributes, we look for the correlation between the average points scored per game. And while this study, we aim to determine is there any significant influence of these physical attributes or not. And during that research, we took all information from the NBA website, which is trustable dataset and accurate also. So let's continue with our data collection description. Totally, we selected 45 NBA players, and it is ensure diverse representatives of the different player profiles. And as you see in the table here, these are their shoe size, numbers, height in letters, weight, and average points. Okay, let's continue. In data analysis, we make three different data analysis. Separately, we look from the correlation between height in the meters and average score counts. Secondly, we look for the correlation between shoe size and average score counts. Thirdly, we look for the correlation between weight and the average score counts. So let's get started with our first correlation between height in the meters and average score counts. So it is basically what we did in the R code of the box plot of the average points by height. Let's see the result. And it is how it seems like actually. In this box plot, you can see the median lines as here, and we cannot make a conclusion by this box plot, but also we cannot deny that there is a intention to like negative side. You can say like that. You can say that if there was a line, it will be negative slope, and we cannot conclude that the physical attributes high can influence to like points points per game like in a bad way, but we cannot deny what we see in this picture. So let's continue. Arcode of scatter diagram of the average points by height. It is the scatter diagram like arcode, and let's continue with the result. Yes, in this one we can see like basically more detailed what we mentioned about it. As you see, that line has a negative slope, and also you can see about our outlines far from the mean. So yes, as you see, so it is the high and it is the average points, and you can see the distribution of this. So let's continue. It is the correlation between shoe size and average score counts. Right now we get the from physical attributes we choose the shoe size, and it is the arcade of the box plot of the average points by shoe size. And my friend Mithat Saffak will continue from this part. So thank you for your attention.
Hello everyone, I'm Mithat Saffak and I'm going to continue from now on. Here in this slide, we can see the box plot of the average points by shoe size. As we can see, as shoe size get higher, the median gets lower. So we can see a minimal impact on the average points scored. Here in this slide, we can see the R code for the scatter diagram of average points by shoe size. As this red line shows, there is a negative slope for the shoe size. As shoe size get higher, the average points gets lower, as we saw in the box plot. Here we can see the R code for the box plot of average points by weight. And in this box plot, there isn't really a trend, so we can't say there is an impact as the weight changes. Here we can see the R code for the scatter diagram of average points by weight. Here, as there's orange line shows, there is a negative slope, and as weight gets higher, average points gets lower, but it has a minimal impact. Here in this R code, we can see our normality test. We used Kolmogorov-Smirnov test. And let's analyze the results. As we can see, all our data have p-values higher than 0.05. So all of them has normal distribution, and we can use them for parametric tests. So let's check our first hypothesis. It's the relationship between height and average points. Our null hypothesis states that there is no significant relationship between a player's height and their average points scored. And our alternative hypothesis is there is a significant relationship between a player's height and their average points scored per game. So let's check our results. As our p-value is higher than the common significance level of 0.05, there is no significance between average points scored and height. So we fail to reject the null hypothesis, and this suggests that height does not significantly influence the average points scored. So from now on, my colleague Yunus Emre Alas is going to continue. Thanks for listening.
Hello everyone, I'm Yunus Emre Alas. I'm gonna continue from there. Hypothesis 2. Weight and average points. Null hypothesis, there is no significant relationship between a player's weight and their average points scored per game. Alternative hypothesis. There is a significant relationship between a player's weight and their average points scored per game. Results for hypothesis 2. The p-value 0.9 is greater than the common significance level of 0.05. This indicates that there is no significant difference in average points scored across different weight categories. Therefore, we fail to reject the null hypothesis, suggesting that weight doesn't significantly influence the average points scored by NBA players. Hypothesis 3. Shoe size and average points. Null hypothesis. There is no significant relationship between a player's shoe size and their average points scored per game. Alternative hypothesis. There is a significant relationship between a player's shoe size and their average points scored per game. Results for hypothesis 3. The p-value 0.3 is greater than the common significance level of 0.05. This indicates that there is no significant difference in average points scored across different shoe size categories. Therefore, we fail to reject the null hypothesis, suggesting that shoe size doesn't significantly influence the average points scored by NBA players. We use the chi-square method for goodness of fit test. Our values can be used because the p-value is greater than 0.05. There is an R code for linear regression model, and these are graphical depictions of linear regression model. And this is the R code for ANOVA. Summary from ANOVA results. 8. No significant effect on average points, P equals 0.256. Weight. No significant effect on average points, P equal 0.867. Shoe size. No significant effect on average points, P equals 0.232. Overall, the analysis indicates that there are no significant difference in average points scored by players based on their age, weight, or shoe size categories. These factors don't appear to significantly influence the average points scored in the given dataset. And this is the R code for Kruskal-Wallis test. Results for Kruskal-Wallis test. The Kruskal-Wallis test results indicate that none of the categorical variables, age, weight, and shoe size show significant difference in average points scored. The p-values for all tests are greater than 0.05, meaning we don't have enough evidence to suggest that these categories significantly impact the average points scored by players. And these are the references. Thanks for listening us. Goodbye.